Okay, we're heating potassium chlorate, and it has melted. And we're going to start decomposing it. And now we're going to put Mr. Bear into the slide of death. Oh no, the slide of death, the slide of death! Oh, oh that wasn't very good either.
Are you putting enough in?
Yeah. He's shooting back out. Oh, here we go, more!
Poor gummy bear of death. That's it.
Fuel, oxygen and ignition. We have hot oxygen in there, and we have fuel. This is Mr. Gummy Bear. Oh no! He's been tried and found guilty of crimes, heinous crimes related to gummy beardom. So we're gonna put him into the slide of death. Oh no! Not the slide of death! Oh no! Go down the slide of death!
You're gonna get hurt, Miss Bush. Yeah.
There we go.
I want it to be the 4th of July now.
Oh no! Not the slide of death!
Marshmallows.
Oh, it's black. No. No.
All right, so what happened? We had oxygen in there. What's the gummy made of? Sugar. Sugar's carbon, hydrogen, and oxygen. So that will combust. And it combusted with the oxygen, made carbon dioxide and water. You can also see there's a fair amount of carbon inside left over from the burning gummy bear. Okay? Good? What do you think, Tiffany?
Because
get oxygen surrounding it. This is what happens in grain elevators. The grain elevator has a lot of dust, and if there's a spark, it can set off a flame and actually explode the grain elevator. Okay? Very
What?
Oh, stop. Stop.
Guys, we're in.
Stop what?
Oh, Jake talking about inappropriate sex.
That's Jake for you.
It's flammable if you drop it in the
All right.
blow up, it's out there. It's like 85%. It's insane. It'll literally blow
So
up.
is hairspray.
Oh, you actually think that?
It's kind of cool. Oh, I want type of one.
A little Kool-Aid. How about a little Kool-Aid?
You know, that's fine, but there's a lot of sugar. You know, it's just not good for you. You know, I would really, really enjoy water. Can I just have some water?
Let's have some water.
put some wine.
Water.
It was red, and she said wine.
Mine is literally the problem.
Why is it doing that?
I'm crying. I'm so confused.
You can actually see
I feel like I'm in there.
I know, it was
down
like,
this is weird.
Okay. What we did
what was that?
before you guys came in, we put some indicators in the bottom. An indicator tells you whether something is an acid or a base. Okay, you guys remember studying, Frontier Trail kids at least went on the field trip to the creek and you guys tested water, and if it was a pH of 7, it's neutral. Lower than pH of 7 is an acid, higher than pH of 7 is a base. All right, so we put some indicator in there, and then the first thing I poured in was a little bit of acid, hydrochloric acid, so it stayed clear. Then we poured out of the pitcher some base, and the base was sodium hydroxide, and it initially mixed with the acid in there, and I poured way more than the acid, so it became basic. And then at the end, we had set up, did you notice I switched pitchers?
No.
I have two pitchers up here. I had set up the second pitcher with strong acid in it, so when I poured the bases back into the second pitcher, it changed it back to an acid and made it go back clear. Okay. So there's a little acid-base chemistry for it.
This clear solution here, is a sugar. It's called dextrose. It's a sugar and sodium hydroxide. So the same base that we used over there is in this guy. And then this one, you really can't see it very well, but it's blue. It's indigo. It's called indigo carmine indicator. It's just a different type of indicator than the ones we used for that. So I'm going to pour our solution in first. Okay, and so indigo, right? What color do you think that's going to be? Let's see if we're right. Maybe.
It's blue right now.
Yeah, it was blue, but it turns green, right? That's pretty cool. So let's go ahead and stop it. Shake it up a little bit. Okay, so it turns green, right? It's like a stoplight, right? So what's the next color on a stoplight? From green, it goes yellow. Okay, so we should be seeing the yellow color change, right? Appear pretty quick. That it should change, turn colors to yellow. This reason is the indicator, just like the indicators over there, it changes colors with a different pH, right? And so the pH is obviously changing in this solution right here. What changes is the fact that in the flask above the trapped in the flask above the liquid, oh, there it goes.
It just changed.
Where's yellow?
It went to yellow, and then now it's red-ish.
So what happens is there's dissolved oxygen in the solution when it's green. It's going to have a higher pH when with the oxygen dissolved in the solution, and when you let it sit, the oxygen releases back into into the air, into the flask, and so now it's got a higher pH. So it's probably a pH of like 14. So if we want to get it back to green, we just pick it up, shake it.
Put a little oxygen back in.
Put a little oxygen back in. And that's that. And it'll keep going.
Are the other ones still going? From earlier in the day?
This one's from earlier. I unstoppered it. But
Yeah, we got some nice red in there.
yeah. See, it's still working. This was from earlier. So yeah, let's turn yellow again.
Yep. All right. You ever wonder where the colors come from? I need some methanol.
What?
All right, I have a little bit of calcium chloride. I have some potassium chloride. I have lithium chloride here. I have some copper 2 chloride. Why is it copper 2? What does that mean? It means it has what kind of charge? 2. It gives away 2 electrons. And we're going to, you'll see. Andrea, will you turn the lights out? And this is where the colors you see in fireworks come from. You'll notice the first one is kind of an orange. The second one is more of a yellow. But can you see at the bottom there's a purple mixed in? That purple is the potassium. Then you have a pink one. The green one, what color what do you suppose the green one is? The blue-green one. What compound? Copper. And the last one's the strontium. When we did the lab with the Q-tips, and you put the Q-tips into the salts and then stuck them into the flame, this is the same thing. This is where the fireworks get their colors. If you have fireworks that are red, they're going to have a lot of strontium in them. Blue fireworks are going to have copper in them, so on and so forth. So that's literally where fireworks get their colors from. Pretty cool, huh? All right, shall we do a balloon now?
I think we should.
Okay, I'll be right back.
Why don't I do this?
I might straighten that already.
Yeah, I got the hiccups.
Done.
Of course, if you can't light a match.
That's good. Rad.
That's right, here we go.
All right, I'm going to do something different this time. All right, now when I blew up the balloons, it popped immediately. Why are these just burning? There's still hydrogen. What do you need for fire?
Oxygen.
We need some oxygen. Now there's a hole in the bottom of each can, and the hole, as the hydrogen burns, air is going in to replace it, and there's oxygen in the air. When it reaches the right ratio, a 2-part hydrogen to 1-part oxygen ratio, it will actually blow, just like the Mythbusters that they did with the methane gas.
And these are louder than the balloons.
These are loud.
Stop it.
Louder than a balloon?
Yeah.
Oh no.
No, I like this.
About to go down.
Oh, they can be louder.
They can't be.
How do you know when it's about to start?
You don't.
That's the first.
Obviously, I got more hydrogen in the second one.
You're gonna
Stop
know.
it. Stop. Stop.
I know. Awesome! We're gonna see what happens when we just catch
One of
fire.
our students is getting her. I believe.
Huh?
One of our students is getting her. She was like, Curtis. I was like, yeah.
Are they coming?
Great question. I probably shouldn't roll off. We'll find out really quick.
I guess.
She will.
Yep, here they come.
Clock one.
Come on in, go to the back of the room.
Oh man, are you surprised?
Dude, why is it so